you understand what we'll do today. We will learn about the most important concept in AI in solving or solving the model or estimating the parameters of the model, and we use what is known as a gradient descendant. Later on, we talk about what does it mean stochastic gradient descendant. I thought just from knowing you a little bit, guys, uh, it would be very instructive for you guys to do one example from A to Z. Estimating the parameters of a neural network like this one, which has thousands of parameters. You don't need to go into the detail, but you understand what the computer does. So what I recommend, let's make an example from scratch. Okay, I prepared something, but I think it will be very instructive for you. Plan, okay? Let's say we have a model. Let's build it up in Excel. Then you can build it up. I think it could be a very good exercise for you guys. Try to do it in JavaScript or do it in Python. Okay, if we have time, we'll do it together. But I think we can do it with Ezio and Daniel, definitely. But let's take an example. Let's say we have a model, okay, which mimic what I'm going to do in this example, okay? I specifically don't want to tell you how I got to this equation, but I will start with something that will eventually will get you this formula, okay? Let me take an example of, let me just take those numbers so I will remember. Let's generate some example, okay? I will remove it. Q square. All right. I will generate out of it. You don't really know what I mean by that in a second. I will explain it. Okay. Let's say we have a formula y equal, bear with me, okay? Bear with me. I will generate it in such a way that will give you yeah, that'll be good. Let's do it this way. Why it doesn't like me? Why it's hold a second. Let's put it this way. Just trying to copy this one. Okay, let's take that one out. Fair. We don't really know that. And that's how we're going to generate. Okay, pay attention to we have here different Q's. Okay, we have Q and X depend on Y. Now, the relationship between, I don't want to do that. Yeah, I will do it this way. I will change it a second. That would be confusing in the beginning. Beautiful. Okay, we have here a relationship between y to x. Okay, if I have data, I put an x here, and I will put a y here. Now, for every x, we'll get a different. You know, we can write it a little nicer here. Maybe we'll write it this way. How about we do it? We'll write it this way. That would be the same. No, you know what? I will leave it this way. Intentionally, I will leave it this way. There's a reason. I will leave it this way. Okay. Now, between x and y. Okay, and it depends on the q. Everybody get it? Please stop me if I'm saying something that is not clear to you. Okay, guys? It's very, very important. Very few people really understand it the way it should be understood. Then they get lost. Okay? We have a relationship between x and y, which depends on q. So if q, let's assume that q is equal to 2. Okay, what will be the relationship? We can look at this equation. This equation becomes to be what? Y will be equal to, anybody want to help me? 2 power 2, that will be 4, right? Minus x times 2, right? Plus x. Everybody with me? See the y did it? We have a relationship between x and y, okay, which depend on q. And in that case, if q is equal to 2, okay, the relationship will come to be the q power 2, it will be 4 minus x times 2, okay, it will be 2x plus x. Or we can really summarize that one to be that y equal, you know, minus 2x, it will be really 4 minus x. Everybody agree? Everybody happy? Everybody? Hello?
Yes, doctor.
Okay, wonderful.
Yes.
So now what this relationship will be? Let's take a different axis. Let's just pull numbers. Let's let's put number. By the way, this is really a straight line. You can tell this is a straight line. So if we take a 1, 2, 3, 4, 5, 6, I'm just making up some numbers. Okay, and 6. What would be y? Y according to that relationship. Okay, you know, one way to do it, which will give you a little more power in Excel. Maybe I'll make it even more points. This is an excellent example for you guys, especially if you don't have the mathematics background. That's going to be a really good example for you. So y will be equal to basically 4 minus x. In another word, it will be equal to 4 minus, okay, and the x, which is this number, correct? Beautiful. So what can we do now? We can take this one and put it all the way this way. We'll get all the numbers, which is really a function of a straight line, okay? Because this is really, as you can tell, y equal to 4 minus x, it's a slope down a line. Now, this is one way to do it. You can do it more sophisticated, okay? You can make it more sophisticated, and you can tell, you know what? Instead of putting here the q, let's leave it this equation. In another word, I can take this one and change it to be, let's make a place, sorry. Let's make a place, we'll put here, maybe the 2, we'll make it here, q equal, and we'll put the number right here. Okay, we'll make it dynamic, meaning we can take now y will be equal to q squared. We'll take this number and put it square. Okay, what is minus x, which is this one, multiply again by this q, correct? Plus the x. Everybody happy? That will be, you see, we're getting the same number, no surprise. Okay, because we originally took the 2, we put it here, we got this equation, then we put it in x, no surprise. All those numbers should be the same. Okay, but let me just change one thing here. So the f1, we want to like this one with f4. Okay, and we take, I think that's the only things that I F4, no, sorry, the G, yeah. Take that one as well. F4, so we can copy it. Beautiful. You see, if I copy this one now, all the way, it should keep the same numbers. Okay, I didn't do any, but now it becomes to be a function of the Q, okay, and the X. The Q is just like a parameter. You can think about the Q is a parameter of the equation. Now pay attention to the beauty. This relationship between X and Y depends on which Q I'm choosing. If I choose a Q equal to 3, I'll get totally different numbers. You see that, guys? Everybody see that?
Yeah.
Okay. If Q will be equal to 1, we get totally different numbers. Well, straight line that this really just doesn't really depend on X at all. Okay. If I take Q equal to 0, oh, I'm getting a straight line. In fact, this is 0, this is 0, it'll be X equal to Y. No surprise. Okay, now let's take this example. I'm intentionally using this one for a reason. Okay, now how this one look like? Okay, how this one look like? Okay, if you look at this example, you can say when Q equal to 2, we're getting some numbers here. You know, when X is 1, so we're getting it a straight line going down, okay, between X to Y. Okay, this is beautiful. Now, let's do it now. Let's do now, what I would like to do is take some numbers, okay? I will choose, hold a second, bear with me. I'm trying to make it so it would make sense to you here, guys. In this example, eventually you can link it, okay? In X4. Remember, let me just mark this one for you. When X is equal to 4, when X equal to 4, Y equal to 0. Let me mark that one. I'll come back to that, I promise. Okay? I'm building it up in a way that eventually will make sense to you. It's really hard. This is one of the hardest things to go through. When you go through that and you really understand it deeply, your life will be much, much easier. Okay, so I'm making an example here, building it up an example will link to that one. You can't really see what I'm doing yet, but bear with me. Okay, what I would like you to just pay attention that we're kind of building up an example, which is kind of one, we have a relationship between X and Y, which depend on Q. Okay, and now, and all what we see in real life is only the relationship between the X and the Y, okay? And based on that X and Y, many times we're saying, which is the Q that actually created it? I will repeat my sentence again. In real life, what do we see? This is not really what you see in real life. Okay, this example, don't get confused. Many people get confused. That's all what you see in real life. This is just one example of what you're going to see as one example of real life. What do I mean by that? How do I get this relationship? Q squared minus 4Q plus 4. Where do I get that one? How do I get that one? Pay attention. Look at the 4 here and look at the 4 here. Okay? Pay attention to that one. 4 and 4. This is really the x in my example. Don't kill yourself if you don't understand me immediately. Pay attention in this equation. We said this is the relationship between the x and the y depend, okay, on the q. Look at this one. If x equal to 4, in this example, let me copy it. I'll put it aside for a second. Pay attention that if x is 4, we're getting this equation. So that's why I marked here this one, okay? If x is 4, okay, this equation is exactly what we see here. Fq is a q squared minus 4q plus 4. In other words, we have a relationship between x and y that depends on q. And if I know one of the x's and one of the y, I can create a relationship between q and y, okay? So if I know in this point when x is 4, okay, the relationship between y and q would be this one. That's a hard one, okay? So the equation that we see here, and we're seeing that y, in this example earlier, I can change it for you if you want. This is only a y. I will leave it, okay? FQ is like a y. But this one is, you can think about this one as a y. Y is q squared minus 4q plus 4. But this relationship is only true, only when x equal to 4. It's like in this equal to 4, yeah. Okay, so the relationship between x and y really depends on q. But if I know one of them between x and y, let's say the x is 4, if I know the relationship, the complete relationship, then I say, okay, let's plug x equal to 4. What's the relationship between y and q? It will be this one. But let me rephrase it. The relationship between y is between y and x and q. So y depends on the q and the x. Is that clear, guys? This is really what the equation here is saying. Let me make it bigger. The y depends on q and x. So if I know the x, the relationship between y would be only depend on q because I fixed the x. But this relationship would be totally different if it is here. If I change to x to be 9. Fair enough, guys? Everybody with me?
Yes.
This is a little hard. Don't kill yourself if you don't understand it immediately. Is that clear, Opio? Ezio?
Yes,
Yeah.
doctor.
All right. So the relationship between y and x depends on q. If I know the x, I can know the relation between y and q. The y and q depend on x and the other way around. Okay? If I know the q, the relation between y and x will be this way. In real life, we see only this one. We only know the relationship between x and y. Now, see the beauty, okay? You know, when I look at real life and let's say this is the only things that I see. I'm measuring the x, I'm measuring the y, and I'm getting that this is the x that I'm measuring and that's the y. And then my question will be, what do you think q probably was? What is the most likely this q was in this equation? I repeat myself, it's very crucial understanding. Okay, I'm assuming this is the relationship, okay? And I'm trying to say to myself, okay, what most likely Q is. If this is what I measure in real life, then you say, okay, you know what? if the x is 4, this is probably the equation. It is not this one. It's only this one. So I would say, okay, this is the relationship, okay, between y and q now, because this is really what I measure in real life. So probably the relationship between y and q is this one, okay? So what is the most likely? What should be the q that really giving me the closeness between y and x? Because I measure, you know, the y becomes to be 0, okay? And the x was 4. So if I'm telling you that's really what I measure in real life, what really the q supposed to be? Why? That will be easy. Why that will be easy? Because now it says 0, that's the y I measured in real life, 0 equal to all that stuff that we have here. And I can solve. In fact, if you solve this equation, you definitely will get q equal to 2. You can really check it. If q equal to 2, that will be 4 minus 8. That minus 4 plus 4 would be 0. No surprise, because that's the way we build it. Okay? Now, this is a subtle point, very, very subtle point. We're assuming the relationship is between y, q, and x is this one. Let me bold it even. Now, in real life, we don't really know the q. We're trying to find that q. We're trying to say, what is the reasonable q? What should be the q if in real life, this is the result? We're finding this x and this is the y. So what do you think the most likely is the q? Fair enough? Okay, guys?
I have a question.
Okay. Say again?
Yeah, I have a question.
Sure.
Why are you focusing on 4 and 0? Yet there
Just
are
an
other
example.
values of
Just because I
just
took
an
just an
example.
example to fit the example we're going to see here in a second. Okay. So that our number will match. Okay. But
Okay.
I will change it in a minute. We can do other examples. Okay. I will take another example if you want, but I'm just trying to build up now. Say this x and y, they are all built, all of those one. By the way, I don't really have to, you know, I can take another one, I can take this one, get the same numbers. Okay. Let's take this one, can take this one. Okay, you can take this one to be -1. Okay, and let's now use x to be, yeah, I want to use x to be 5, correct? It should match, right? You know, take now 2 squared is 8 minus 10 plus a 5 will give you -1, correct? There we go, let's write it. That will be 4 minus 10 plus 5, right? Let's give you a -1. So all those dots, you know, I just took that one just because the numbers that we eventually will end up would be similar to the other one. So for different x's and different y's, all those one match, okay, the reality, okay, this one, all of those match the reality in which q is 2. They are all supporting the idea that q is 2. So if I'm looking in all those dots, the relationship between x and y, and I'm asking myself, what most likely should be the q? What is the q that's keeping the relationship between x and y? It will not be q equal to 3, okay? Because in 3, this relationship will not hold anymore. Okay, it will be 4 and 1. Okay, so let's summarize, and then we'll do it a couple times. So don't get don't be intimidated or don't be lost. I mean, even if you get lost, don't feel bad. It's not easy. Let me just repeat it again. When Q is 2, the relationship between Y and X is this one. It's Y equal to 4 minus X, okay? And this one reflecting in real life the relationship between those two. Now, if I had those numbers so beautifully linked to each other, okay, what can I do? How can I find that Q? How can I find what would be, see, in real life, you really don't know the Q. I'm just giving you numbers that I kind of generated them knowing the Q is equal to 2. But in real life, you really don't know the Q and you try to estimate the Q. What is the Q that makes the relation between X and Y according to what we see in real life? So what do you do in real life? You try to like what I did here. Okay, I can assume, okay, Q is some number. Let's say now, let's keep that one. Okay, let's do it again, but this time we do the following. See how you do in real life. This time I'll put the 3 here. Of course, I kind of like that one here. Let me just change that one to be J. I hope you're not getting intimidated by Excel here. I'm assuming that you guys know Excel well. Okay. See what we do in real life, and then I will explain how the mathematics does it. Okay. That's what we're observing in real life. That's giving in real life. Okay. In real life, what's happening, we kind of, okay, let me put that one. This is real life. And the true Q is 2. But we don't really know it's in real life. The only things we just observe that one. So what we're trying to do is, let me do that. Okay. What we're trying to do in real life, we only observe those data and we try to estimate the Q. We don't know it. If we start, let's say we're assuming, let's say 4, if Q, we think Q is 4, what do we recognize? That those numbers don't really match what we see in the sample. We call that one is the sample. That's what we see in real life. If we assume that Q is 4, we're realizing that this relationship don't really hold with Q is 4 because those numbers are very different than those ones. So what do we do? Try to do? Oh, we see what this is too high, too high. Maybe we'll take it lower and make it 3. Bingo, we see, oh, this is getting even closer to what we're measuring in real life. So, okay, you know what? Let's move it, reduce it. Let's say someone said, okay, let's reduce it to 1. Oh, this time, oh, it's still far away. So maybe we reduce it too much. Okay, so we'll say, okay, let's go into 1.5. Oh, it's getting closer. Oh, wonderful. So let's try maybe 2.5. And we see those numbers too high. When it's 1.5 is lower. So maybe we're going to it's even 2.2, something like that. Okay, and we continue playing with it until let's say 1.8. We're getting closer and closer from those 2 directions until we eventually said, you know what? It looks like if I put here a 2, oh wow, perfect match. Probably the equation is with Q equal to 2. Okay, so probably if I view that one in real life and I will look at this equation, probably the Q is 2. I don't really know this one. I cannot see in real life. It's not visible in real life. All what I see in real life is this one. I'm assuming this is the relationship, and then I'm trying to find this Q such that after I measure it, it will be close to what I measure in real life. Everybody got it? This is the hardest, one of the hardest issues or understanding. Everybody got it? Don't be shy. I can repeat myself. Not easy.
I have another question.
Sure.
How do we know that this yellow one, the yellow area, is the
I measure it.
actual? You
I measure
measured?
it in real life.
Okay, perfect. Thank
Think
you.
about it, it's not the one match real number, but think about a machine, okay? That if I give it some power one, it will give me this one. If I give it two, that's what I will measure, etc. The Y depends on the X, but how much X affect the Y depends on the Q. But I don't really know the Q. And the only things I'm measuring is those ones about the machine, okay? And then I said, okay, I know in physics, this is the relationship. And the Q, I don't know what it is, okay? And based on what I'm measuring about this machine, probably this machine has a Q of 2. That's why this is the relationship. How do I find it? I go the other way around. I say, let's start playing. I know this is the relationship, but let's try. If, as I played before, if I put a 5 here, oh, this is not a relationship because that's not what I view in real life, okay? So this is probably not the right Q. Maybe I will put number 1, etc. And I'm playing with that until I get a number Q, which give me this one close, and then we'll find out this is a 2. Now, let me just jump. Looks like unrelated, but it's big time related. There's another way to solve it. If I look at those one and I look at this relationship, okay? These ones, it really is like plugging in this equation x equal to 4, correct? This is what generating. Okay, if I take one of them, let's take just one example. Let's say x is equal to 4, okay? If I take x, I can take one example because they're all really beautifully matching. It doesn't matter, I can use any one of them would be the same, okay? The only thing is that I would like to see and I plug it here, the relationship it will confuse you for a second. I know that, but bear with me, okay? If I take and I plug x to equal to 4, and I plug it here, y becomes to be depend on q only, because I kind of fix the x. What is the relationship between q and y? Okay, this becomes to be an equation. It's not really now x and y. It becomes to be y and q. I can make here x. I can make a q now and y. Now, what is the relationship between those two? It's a parabola, right? You can tell. By the way, if you make the chart, I just took that one exactly like in here. You see, in this equation, q squared minus 4q plus 4, it still is a parabola like this one. So you can do that the same as I did before. Let's use some different q's. This time I will, let's do 1, 2, I'm just making it up, okay? This time is q and y, and we can write the equation here. What is this one? It's q squared, meaning take this one, power 2 minus 4 times q plus 4. Okay, you get now a parabola like this one. You'll see those data, okay, 1, 4, whatever. So we're getting, in fact, maybe I will what are we getting here? Maybe I will use smaller numbers here. Maybe we'll make -5, -4, -3, -2, -1, 0. Okay, let's do it this way. Why did I do 5? Okay. Yeah, let's put it this way. Then take this one all the way down. We really are getting a parabola, you can tell. Is that right? What do you see here? It's really interesting, and if you follow, you will like the idea here. It's an amazing idea which works so beautifully in all AI. Pay attention, this one, when Q is negative, it's a high number. And as Q goes down until I get to the 0, I'm getting, this is the minimum point. And then it's going up. You see that? Fair enough, guys? There is some point in which, okay, to a specific Q, okay, I'm getting a parabola. And that parabola, okay, it has a minimum point, okay, in which minimum point it's given. In fact, I think I have an error here or something. Am I in error? Is that right? When Q is 0, yeah, that cannot be right. I think I have an error here. The 0 is supposed to be when Q is 2. So what is my error here? Yeah, I'm missing the, yeah, I think this is the error. Correct? Is that right? Yeah, I think so. Beautiful. Yeah, the solution should be see, when the Q is 2, that's what we're expecting to get the 0. Okay? And that will make sense. Okay, so there is a point in which the relationship, when I take this X equal to 4, I plug it in. Now I have a relation between Y and X. And one is this relationship between Y and Q when X is 4 will be a minimum point. It has to be exactly when Q is equal to exactly the one that generated it. Otherwise, it won't be 0. Okay? And that's really the game between what we see in real life. That's what we see in real life. And then I say, okay, if the real relationship is this one, let's take one example. Let's say this one from real life. Plug it in. I plugged it in. I'm getting this relationship. Okay? Now I'm making relationship between the 1 and the Q. Okay? And why this will be only, I will get Y equal to 0. Why do I get it exactly when Q is 2? Just think about this, the way we built this example. Because when X is 4, Y is 0. And this 4 and 0 were generated when Q was 2. Therefore, when I go backward, I plug an X equal to 4 here. The 0 will be only when Q is 2, because that's the way we generated those samples. That's a hard one. Okay, I hope that's will sink in eventually. Okay, let me give it another try. Okay, we have a relationship between a Y and an X and a Q. I plug a Q to be something, and I'm generating numbers in real life. Let's say I took, in fact, real life is like I'm taking a machine that the Q of the machine, every machine has its own Q. Okay? I took a machine that has a Q too. Therefore, no surprise, this is the relationship between X and Y for that machine. Then I say, okay, for that specific machine, let's put an X equal to 4. What am I measuring? Y is equal to 0. Fair enough? if I know this is the relationship between the y and the x and the q, and I know that when I is plugging x to be 4, y must be 0, I can put the 0 here in the y, and I put the 4 here. Q must be, what is the solution of this one? It's 0 equal to this equation. Let me copy that here. And then when I solve it, it has to be q equal to 2. That's the way it's built. Okay? No surprise that his equation, this relationship for different q's will get a different y. But when q is 2, it has to be 0. This equation will have to be 0 and q because that's the way we build those numbers. I hope that's clear. That's a little hard. Okay, that's one point. Very, very hard one, but it's worth understanding it. I will repeat the third time. Okay, we know that we have a relationship in real life between y and x and q. And we're measuring a machine that has this relationship. We know that machine has this relationship. And then we take some sample for that machine. And we're observing when I put 1, y is 3. When I put 2, y is 4, etc. And then I said, okay, if that was really the measurement for this machine, let's just take one of them. I could have taken that one, by the way. If you plug here 3, you will see if you plug here 3, and is, okay, and now you use x equal to 1, it has to match 2. It's true for all of them, but that's the way those numbers are. They are all around q equal to 2. So this relationship always hold here. The x, if you change, instead of, you'll get the y has to be equal to 3. If you put here 2, the x to be 2, you'll get the y should be 2, etc. So if you take any one of those and you put them in this equation and you solve it, q has to be 2. Fair enough? For any other q, now for this, now, so what do we do in real life? Okay, we just take one example and we plug it in here. We're getting now a relationship between y and q. Then we say, which q is the one that really fit this machine? And we just plug the relation between y and q now. It has to be, it will get to a 0 when we're getting the right, so we'll get the y to be equal to 0 exactly when q is the original one. Otherwise, it would be a different number. Okay? So we're really looking for the point of minimum when this function gets a minimum. That's why we can find the real q that underlining those relationships. Okay, I hope that makes sense. Now gets a harder second point. Okay, second point, and that's what we actually do. This is just introductory. Okay, in real life, you really never have such a perfect data. You saw if I plug a 3, you'll get the y. When I plug 1, you'll get the 3. If we take the same example, okay, and as somebody asked before, and I really like that question, okay, if I put a 7 here for x instead of a 4, well, I expect the result to be -3. Okay, and you can check, it will get you exactly equal. Okay, but real life is not like that. When it's, you know, sometimes it's just a simple one. Let's say the actual relationship is this one. But in real life, when you measure the x and you measure the y, the measurement is not perfect. So in the real life, sometimes you don't really find a 3 here. You get some error. So let me add some little error to it. I think we did it last time. Remember that rand, I think it was the function, wasn't it? Yeah. Yeah, you see, I just changed the numbers here. So all of those one now will not be perfect. This is what I have in real life. I just changed the, what is the format? Let's just make it to be. How do I change that one? I always forget. And 1, 2, 3. Let's just do it that way. Okay, beautiful. So I just rounding it up. In real life, you know, you take measurement, okay? And the numbers won't be really, maybe I'll make it a little, I'll just multiply it by a small number. But okay, the measurement will not be that bad as I did it here. I just put a small number. So it's close to 3, you see, it's not exactly 3. So when I measure, when I put 1, if I put in this equation 1, we know this is supposed to be the should be really, I'm measuring minus 2.9, but the equation says it should be really minus 3. But in real life, I'm not really measuring this one exactly. So what do we do? Okay, what do we do in real life? We say, you know what? You're finding here that the minimum, what did I do here? Hold on a second. For a different Q's, okay, those are really supposed to be the Y's, okay? So what we do, we instead of just doing it for one specific number, let me now clean up the whole things. So it'll be, maybe I will keep it so you'll have it. Yeah, I will keep it. All right, let's see what we're doing in real life. In real life, we said, okay, let's take this example. Under this example, okay, the Q will come in this example, instead of putting here, you know, I'm putting an X, the Y, instead of the Y will be exactly 0. I'm measuring that it's supposed to be 0.075, okay? So I'm trying now to go to here and plug in the number 0.075. Okay? If I solve it, the Q will not be exactly 2, will be very close to 2. Everybody got it? Maybe I will copy it to here. So you'll see what we really do in real life. Okay? If I solve this equation now, the Q will not be exactly 2. It will be close to 2. But, sorry, maybe I'll keep that one. Something I will do here, okay? What am I supposed to do here? I'll put the X to be 7, but when I'm measuring the real life, it tells me it's minus 2 point. So in here, I'll put the number 2.954. Pay attention, now I'm getting closer to real life. I do the same things, okay? I will do the same things for all of them. So maybe now I will change it to an equation. Here I just wrote the numbers, okay? You know, I keep doing the whole thing. Pay attention, I'm getting a lot of those kind of equations. And I can solve for each one of them the Q. All the Q's that I will measure, they will be very close to 2. They will not be exactly 2. I can take an average, and the average probably will be close to number 2. And that's the way we can estimate the Q. This is one way you can do. Okay, guys? So in another word, I take every sample, plug the X and the Y into this equation, solve the Q, and from that Q, I can take the average. That's one way you can do it. Okay? That's one way you can do it. And that will be okay way, But there's a little more sophisticated way in doing it. Okay, first of all, there's two things really here. One, if you pay attention, okay, we're trying to solve this equation. And how do we solve that one? We move, we can take, we can start solving a quadratic equation and we take the Q out and then we get a solution, which is close to 2. Okay, the same things we do for each one of them. This is one method. And now I want to switch another method. This is like the gradient method. Okay, there's many methods in physics if you study. There's many, many ways. But let's just take one simple one and let's focus on this equation Q. I'll copy it. How you can solve this equation in a different way. And this one, I will do it now using what you already have on the website. Okay, pay attention to this equation. It's exactly what we have here. Instead of FQ, I just call it a Y here. But it's exactly the same equation. What are we trying to do here? We're trying to find the Q that give me the minimum, because the minimum, it's really the one that probably have generated this point. One more time. That's why I did all these examples there. Pay attention to the one that is the Q I'm looking for. It really is the one that's giving me these two minimum. And the minimum would be, in this example, would be exactly 0, because the Y happened to be close to 0, okay? So it could be different number. If the 4 instead of this 4 could have been 8 or whatever, it will give me. But the key point is I am finding, and the minimum point happened to be when Q had this data. So let's go and look at this one. If I have this chart, this is like making this chart as a graph, okay? What is that minimum point? This one is here. We already know it's a 0. But we're trying to find it, instead of solving it, of making Q squared minus 4Q plus 4 equal to 0, I want to solve it differently. And I'm noticing the situation that if I try to put a Q higher than the 2, let's say I put a 4 like I did originally in here. Okay, when I put in this example, if I put a 4 here, those ones are far away from those ones. You got it? They are far away from those ones. And even more specifically, this one is different from this one. Okay, so I know this is incorrect. So I can say if I put a 4 here, I get a high number, like this 4. So let's go and look at this. If I plug a Q equal to 4, the value of this function is high. It's not really a 0. Okay, I got a 4. Okay, and I calculate, now it's a new concept, I'm calculating the derivative of this function. What does it mean, derivative? I don't know if you remember, in calculative is measuring the slope of the function. So, and this is the derivative, 2Q minus 4. How do I get it? Derivative of Q squared is 2Q. Derivative of minus 4Q is minus 4. Derivative of 4 is 0. A constant has a derivative 0, okay? And, okay, so if I calculate the derivative, I get a derivative which in a point of 4, I plug here a 4, it just happened to be 4 times 2 is 8, minus 4, it's 4. So the slope is positive. Pay attention. Why it's positive? Because I'm really on a point in which the function is going up as I go increasing the Q. What happens if I know the slope is positive? If I increase the Q, if I plug here in a Q instead of a 4, I'll put a 5, it will go to a higher number. But I don't really want it to go to a higher number. I want it to go to a lower number because I'm looking for the smallest number of this one. Remember, we're looking at the minimum. We're trying to find this minimum. In here, we saw that if I am in 4, okay, I don't want to go higher. If I go to the 5, I'll go to the 9. I want to go into and reduce the function. So if I see the slope is positive, I most likely should go down. I should go to the 3. You probably give me a lower number. So here we go. If we are in the 4 and I see the slope is positive, I would say let's go down. Let's reduce the Q. If I reduce the Q, what happened to the slope? Please pay attention. If I go to a Q of 3, if I plug in the derivative 3, it will be 3 times 2, it's 6, minus 4, it's 2. It's still positive, but it's a smaller positive because the slope here will be lower. It will be like this one. Still positive, it means I really should reduce it even more. 3, it's not probably not the solution. It's not the minimum of this function. Let's reduce it more. And that's really what we do. It's like, if I am in 3 now, oh, the slope probably still positive. Let's go into the 2. Oh, in the 2, what happened? What happened to the derivative in 2? 2 times 2, it's 4, minus 4. Oh, it's 0. What is the 2? The derivative 0, it's always, if you remember from calculus, the derivative equal to 0, that's what we call extreme point. It's a min-max point. And this example is the minimum point. So we are happy. Wow, we got to the right one. So what the conclusion from putting some number into the derivative, if the derivative is positive, we want to reduce Q. And if we reduce, we want to continue reducing until we get to the point the derivative is equal to 0. And then we know we got to the right number. Now, I want to do the other way. Let's say I started from a Q, which is small. Let's take a Q, I don't know, minus 4. Minus 4 times 2, it's minus 4 times 2, it's minus 8 times minus 4, plus a minus 4, that will be minus 12. Let's look at the Excel here. If I use minus 4, like here, okay, this is really, we see the function is positive. That means we're probably here. We are in somewhere here. If I use minus 4 around here, probably the function is. So what am I supposed to do when the derivative is negative? That means the slope is negative, going this way. If the derivative is negative, I should reduce the Q. I should go toward this point. And I will continue reducing until I get to a point in which the derivative will be 0, which is exactly when Q is equal to 2. In other words, if I see it's still positive and the derivative is still negative, I will continue reducing the Q. And I will continue until I get to the value of the function is 0 in this case, and the derivative will be equal to 0. Let me summarize. It's a little hard and I will tell the whole thing. What is the process? We're getting a sample in real life. We're getting a real life sample, this one. This is more close because we'll have some noise, we'll have some measurement errors. Okay, so I won't measure exactly 3, I won't measure exactly 2. So this is the numbers I actually measure about a machine. Okay, I work on a machine, I put an input to the machine, I measure this one. I put the 10, I measure this one. I collect the data. Now I ask myself, well, which kind of a machine is it? What is probably the Q of the machine? How would I do it? I say, okay, you know what? Let's take one sample. Okay, let's take one sample. Let's take this one, okay? And plug it in this equation. Now, the equation here becomes to be relationship between Y and Q. So I'm getting this one. And then I say, okay, if I plug this one into this equation, and this is the relationship, why this one will be the minimum? Because the minimum, it's the one in which that's original Q was, okay? Because this relationship becomes to be based on Q equal to 2. Any other number will give me a higher number. Okay, so I'm trying to solve now the relationship between Y and Q to find the Q based on these 4 and 0.019. Okay, and then I'm getting this is the result. The truth of them, I want somebody to say something. It will be beautiful if somebody will catch and point here. It will be beautiful. What do you think? Did I make an error here? What do you think? Did I or no? Anybody? I don't think so. Did I make a mistake? Did I make any error?
I
You
don't
guys?
think that it should be okay. There's no error.
Yeah, no error. You're right. Okay, good. Okay, but our objective is really finding this Q. Okay, and this Q, the minimum point, it's based on one sample, one number. Pay attention. Can I repeat the same exercise, okay, using more samples? Okay, and how would I do it? Anybody have a solution? Anybody wants to? Okay, we understood that one now, correct? We understood that one. Fair enough. We got that the minimum will be exactly when Q equal 2. Is there something we can jump and be a little more sophisticated? Anybody have an idea? How about we go back to this one? We haven't used that one yet. Let's go back to this one. What is this number 13 come from? Remember this 4, the Q equal 4. What about if it's 2? We're getting those numbers very close to this one, am I right? Everybody agree?
Yeah.
Beautiful. How about if we make those one now, not based on this 2? How about I'll make this one as a function let me measure it to be, just for the fun of it. Let's take, okay. Let's do the following. Okay. Let's now try to do what we did here in explicit for 1 point. Let's do it now in slightly different, and your seats will get you beautiful results. Let's take now I call it delta Y. And what do I mean by that? Let's take now the difference between this number and this number. And I will add another things. You know what? Let's start this way. And then you will see why I'm doing what I'm doing. Okay. Why all of those happen to be positive, which is interesting. Let me take this one to be even smaller, maybe. Maybe I will be lucky to get some differences of negative. No, I'm not getting anyone negative. Yeah, here we go. Maybe this one. interesting. I would expect one of them to be interesting. Anyway, some of those could be negative. I wanted interesting. This is random. They are all positive here. And what I will do. Leave it. I don't want to get confused. You'll get confused. I wanted it to be negative, but the way I added the randomness, it will be always higher number here. But that's okay. Or give another example, which will have negative, and this one could be negative and positive in real life. But let's leave it. Okay, we're getting the difference between this one and this one. This column wise and this one in here. And pay attention to this one. It's a function of this Q. Fair enough, guys? Okay. Now, I will do it the way it's really done. And in the future, I will show you that this difference could be negative and positive. For now, there's a reason why we always get it positive. It really should. It could be, I'm just adding a positive of numbers. You know what? I know what I will do. I'll give it to you. 1 second. That's what give it to you. Yeah, that's what do it. Okay. Yeah, okay. Say the numbers will be, say this random give you numbers between 0 to 1. Okay. If I subtract half, the random will be now between minus half to a half. Okay. So the random really is, I'm trying to get random measurement error could be plus minus. And that's why the measurement sometimes will be above, sometimes will be below. And now when I'm comparing it to real, what it is, the difference sometimes will be positive, something you see here it's positive, here is negative. Okay, this is good. Now, in order, what I'm really care is how far is really this one from this one. And the distance between those two, okay, I want to measure the distance. I don't really care if it's a negative and positive, because differences means that my measurement, my estimation is not perfect. So I will take that one and make it power 2. This number will always be positive now. Okay, if I take a negative and square it, it will always be a positive number. And maybe I will make it this way. Where is the cell format? Here we go. Here we will always get a positive numbers, okay? It's the difference square. It's the difference between the y's square. Okay, let me copy this one to all of them. Okay, how come? Maybe I should, hold a second. I should really make it, because it, you know what, I will increase the randomness here. Let's make it 0, 1 now. That would be better probably, yeah. Beautiful. Okay, this is now giving me the difference between this y and this y. Pay attention, this one, it's what my assumption. This is the real one that actually generated it, okay? And I'm trying to find the good one. So if I put here 3, okay, the difference will be very high. Okay, as we said, this is really far away from this one. And the one that will be giving me those numbers getting close to this one, it's only when this Q, it's very close to this one. When this one will be exactly to this one, the difference will be almost 0. So let's take the sum of those differences. We're almost done. I will repeat it next time. Okay, what is that? This is probably the hardest session so far that we had, but this is would be used so much, and I'm not going to repeat them. Okay, so what do we have now? We have, this is the sample. We know that it's very close to this. This is generated by this one. Okay, now we say, you know what, instead of taking just one example and taking like what we did here and trying to find the minimum, we'll have and then doing for solving. Instead of doing this one, could be a better way, which the computer will do it faster, and I will explain why too in a minute. Let's take the equation here and just plug different Q's. Okay, let's type different. If I put a Q3, this is really what's supposed to be the result. And then I measure the difference between what actually I measure in real life to what it's supposed to be if Q was 3. Then I find out there is a big difference between them. And I try a different Y, a different Q. Let's put it's 4. Oh, this went up. I'm in the wrong direction. If I go into here and I put here 1, it's still high. Okay, and I put here a 0. Oh, it's high. It's probably not 0. It's not 1. And if I put 2 here, oh, the difference will be very low. Theoretically, it should have been 0. Yeah, but we have some randomness, and that randomness will never give you to be equal to 0. So now here is the real beauty, and we're really jumping even beyond. What this example is just really one sample when you have x equal to 4 and y equal to 0. And we did that one in this example here. And here we're kind of really jumping. And with that, I will finish. Okay, this one, we had one example when we take the derivative and we find it's equal to 0. What do we do now? That's the hardest one. And with that, we'll conclude. I will summarize. See what we did now. We said, okay, we have this sample. Let's put some Q, and that Q will generate what it's supposed to be, if that's the real one. We take the difference between all those data, if the Q was 2, that's what it's supposed to be. This is really what we measured. We take the difference between this one and this one, we get a difference and we square it, and we sum it up. This summation becomes to be a function of these 2. And now it's, as we did the derivative for one example here, I'm sorry. This was one example. Now what we do, we're taking all of them. Now the difference between this and this is depend on the 2. The difference between this one and this one also depend on the Q. All of them depend on the Q. So this summation depends on the Q. This summation, which I will mark here, depends on this Q. I can take the derivative of it. We don't have to do it. The computer will do it. The computer will tell him, take this summation, take the derivative. And if the derivative is positive, reduce it. So if I put a 4 here, this function becomes to be, the derivative will be positive. And then the computer will know if it's positive, start reducing the 4, reduce it to 3.5, let's say. You will see this number will go down. You see it's going down. Oh, calculate the derivative again. And find out it's positive, so then he knows I'm supposed to reduce it. So let's reduce it to 3. You'll notice the number will go down. Calculate the derivative again. If it is positive, continue reducing. So he realized is reducing to 2.5. Oh, it's keep going down. Calculate the derivative. If it's positive, continue reducing it. So you're going to 2.25. Oh, it went down. See, it's really getting closer and closer. keep doing it. Okay, so it's going to 2. Beautiful. Oh, very low. And by the way, that's when I started from a high number positive. How about if I started from a number -2? Oh, a high number. You calculate the derivative. You find out the derivative is negative. If it's negative, I should increase the Q. So you're going and it start increasing, meaning it's going to change it to -1, let's say. Pay attention, the numbers will start going down. Beautiful. Oh, calculate the derivative, still negative. If it's negative, continue increasing it. So I go into the 1. Pay attention, it's going up. And you keep doing it until it ending up eventually to be 2. It doesn't matter if I'm on the left or I'm on the right. I calculate the derivative. If the derivative is positive, I reduce the Q. If the derivative is negative, I increase the Q. And that's the way the algorithm in the computer does it. I give him the sample. Okay. It calculates what it should be under that Q. It calculates it. It takes the difference between this one and this one, square it for each one of those samples, add them up. You get this total. It takes the derivative of this total of that Q. If in that Q, let's say start, by the way, start, let's say from number 5. You calculate the derivative. If the derivative is positive, you start reducing the Q. You keep reducing until it gets that one to the minimum. If it's negative, it start increasing, okay? And increasing until it gets it close to the 0. Somebody should really ask a question, how much it decrease or increase? Let's say it started from 5. It found the derivative is positive. By how much it reduced the 5? Does it reduce it by 1? Does it reduce it by 2? Sometimes I'm telling him, that's called a learning coefficient or whatever you can call it. It's the learning rate, okay? And I can tell him, you know what, reduce it by 1. If I tell him reduce it by 1, you know what, I tell him by 2. From 5, it will go to 3. And boom, it's going down. Calculate it, it goes to the 1. And pay attention what's going to happen now. You reduce it by 2, oh, you're getting another positive. You continue increasing it. Well, I find out now that the derivative will be negative. It has to go back now. If it goes by 2 again, it keeps flipping back and forth, back and forth. We'll deal with it next time, okay? By how much it should reduce or up or increase every time until you find the minimum. That's called a learning rate. And this learning rate, you be sophisticated. You can even tell him the beginning start with a big learning rate and then decrease the learning so you can converge and don't flip-flop until you get lost. And this is one point that we'll deal with in the future. But that's really what the algorithm does, okay? We're getting a sample, and from the sample, we from the sample, we're building up under a specific Q. We take a random Q. We calculate what is really supposed to be under that Q. We take the difference, and that difference, we take square for each one of them. We sum them up. And then this one, we try to bring to a minimum. And in calculus, we learn a function that depends on Q, okay? We take the derivative. If the derivative is positive when the Q is whatever we put there, if it is positive, we reduce it. If it's a negative, we increase it. And we keep doing it until that one gets to a minimum. That method called gradient descendant. The derivative called gradient, it's another concept. I will talk about it more next time. Here we took an example. We have one variable. Sometimes this function could depend on more than Q. There can be Q1, 2, 3. It can be many Qs. And you can imagine how complex it gets. Instead of having one Q, it can be 2 Qs. And then the derivative we take It's not always the Q, but Q1 and Q2, and that's getting much more complex. When you have a function depending on more than one variable, the derivative is considered as a gradient. Gradient is the derivative of the function by all the parameters. I will repeat it next time, okay? I don't want to make this session too long. It's already got too long. All right, I will stop here. And